was my question. There must be a point. You're saying no, the Earth is too big,
Yeah.
but how do you see the sun then? You see the sun, you see the moon. They're millions of miles away. So there must be a point where you can, because you're not you'll be on a point on the ball where you can look up and you can see that convergent line. It's the same as being in the
Yeah.
room, isn't it?
Yeah, the sun works the same way. It crosses directly over your head at the equator. But the further towards the poles you get, the lower and lower down on the horizon it gets as it crosses overhead. But you're not there. I mean, I don't understand what you're saying about the stars. I know you're trying to say where's the point where you see both rotations, and if I'm not mistaken, they have pictures, time lapse pictures, where you can see both rotations coming together over your
That
head.
I'd love to see it though.
Let me find it. I'll show it to you.
Yeah, if you say there's
Equator.
pictures, why they got pictures and not videos?
Because it's time lapsed. They probably do have videos actually.
If it's a time lapse, it must have been in motion. Otherwise, you
Yeah,
wouldn't.
yeah, it's
Like,
star trail pictures, which means you use time lapse to make to see the trails.
but even if you do see that, it's still not proving anything. Even if even from a globe's perspective, it doesn't prove anything. It's only an illusion
Of
because
course
we
it does
know.
prove it. Do you want
We
me
Then
to
know.
why?
explain it to you?
Well,
Well, then
if
why
we,
did you
Would you like
ask
me to
where it was
explain it to
at
you?
and you wanted to see it?
yeah, because I want you to know what your position is. You believe in that, and it is a belief. That's what I just want you to, like to see. You have to ask these questions for you to, because like, look, you sit in a room, you're watching a ball, and it's spinning the same way, but the illusion it creates is that there's different rotations, but it's just an illusion. It doesn't prove anything.
It most certainly does prove it.
Oh my
You
god!
want me to explain it to you?
No, you're not drunk as well, are you?
No.
Okay,
Well,
go
you
right
ready?
ahead.
Okay. Well, let me just ask you a couple of questions first.
No, no,
Do
no,
all the
no. You're
stars
going
ro-
to
do
explain
all
it,
the stars
and you
rotate
don't have
around
to
one
ask me
central
anything.
point?
Pardon?
Do all the stars rotate around one central point?
I don't answer questions.
Of course you don't.
No, because
Are
like
you
you said,
interested in me explaining it or
hold
not?
on. You just made the statement that you was going to explain it to me. Then the first
Sure.
thing you said, I need to ask you a couple of questions. No.
Yeah, yeah,
Explain
because
what?
I want to get us on the same
Yeah, I'm not
on the
on the
same
same
page.
page. Never going to be on the same page as you.
Okay, all right. I'll go without you. All right. So according to the flat Earth people, including you, if you're a
I'm
flat
not a
earther,
person, so like
okay, then
you're not
all
including
the
me.
stars rotate around a single point. Now, if all the stars are rotating around a single point, how is it I can face directly south, look at the Southern Cross, and see the Southern Cross turn upside down during the night?
No, Phil, they rotate
Why
between
doesn't
2 points. 2 points.
why doesn't the Southern Cross go horizontally across my field of view if they were all rotating around a central point?
All right, is that for somebody who thinks that? Because I would say they're rotating between 2 points. There's two poles.
What? That's not how the Southern Cross rotates. The Southern Cross just turns upside down.
Yeah, I don't think you're listening. I'm not. Is somebody in here saying it's that everything's going around the north? They would have to answer that if that's who you're. If that's
What the flat earthers say. The flat earthers say all the stars rotate around a central point, which is Polaris.
well, not
All
everybody
the
says
flat
that.
earthers say that. All the
That's
flat
false.
earthers say that.
That's false. Because many think it goes around two poles, which it does. There's two poles. So not everybody thinks they all go around the north. That's just
Yeah,
I hear you that some say that though. There's some people that have a planar stationary Earth who also say that, but I'm just saying not all of them. Not all people who have a stationary planar Earth think that they all go around one point. Many
Okay, good.
agree they go around 2 points. There's the northern stars
All
that
right,
go around the northern pole, and the southern ones that go around the southern pole.
I'll take your 2-point reference. So the one of the points is Polaris. Would you agree with that? Do you agree with that?
The celestially, yeah, the celestial pole.
You agree that's Polaris. Do you agree with that Polaris is above the North Pole?
Well, it's a little offset from the center, actually.
Yeah,
And
so
it's
you
also-
agree with that part. Where
Yeah.
is the other? Where's the GP of the other one?
Sigma Octantis, below Sigma Octantis,
Where is that?
at the South Pole region, where you can use the southern pointer stars and the southern crux to find the intersection where Sigma Octantis
Yep.
is, and use that.
So,
That's the point.
good. So how is it that they move in a circular way, vertically, if you like, instead of horizontally? If you're looking at something that's above your head, even if it's in the distance and it's moving in circles higher than you, it'll look like it's going horizontally. It's not going to look like it's going vertically, which it does, and which matches the globe, by the way.
I think I might see what you're trying to say. You're saying that if the
Yeah.
stars were on like a flat disk, it would look like skewed, and you wouldn't see them at a like a vertical, the way you see the southern star trails or the northern ones. Are you saying that? Is that what you're saying? That it would be like skewed because it would be on a flat ceiling, and it wouldn't go down to the horizon and look like it's vertical?
Correct. Exactly. It'll just be flat. It'll just be horizontal.
Okay, but
And
are
in
you
fact, the sun-
are you
in
going
fact,
off of
the
that
sun
from
would-
the idea? Are
The
you
sun
going
would do the same thing.
Okay, but are you going off that from the idea that the sky is like a flat ceiling? Is that what you're going off? Or
You got a different version?
well, yeah. There's a lot of different concepts of how the sky could be working. But I'm just
All right.
saying, are you thinking of it as like the stars are like some kind of objects in a flat plane of a ceiling?
That's the flat Earth view.
Well, no, because some people think
Even with the two pole ones, unless what do you think the Sigma Octantis is stuck in the side of flat Earth, in the edge of flat Earth? Is that what you're thinking?
wait, what do you mean?
What about the sun? Does the sun go around in concentric circles around Polaris, around the North Pole? Does the sun do that?
For 6 months,
The sun,
for 6 months. I mean, the whole thing I think is a toroidal field. That's why it has a spherical nature to it. I don't think it is just like a flat, ceiling with like light bulbs in it. Because I do hear what you're saying. There's other issues actually with the angles to stars. If that were the case, there's actually other issues with the way that the stars actually move and the angles to stars. It matches more of like what a planetarium is. When you're in a planetarium and you have a domed ceiling, you need that shape to properly represent the stars. You need that hemispherical shape. That's why you can't really make an accurate planetarium with like a flat ceiling. So to me, that would indicate that the sky does function that way as well. Now, how is it doing that? How is it making that hemispherical shape and structure? And what are the stars and what are they? That's a whole question in and of itself. But yeah, I mean, if you're debunking the idea of the stars being like on a flat plane at some height and then they're just stuck up there like little light bulbs, I would not necessarily disagree with probably some of the arguments that you would make with that, because I would agree that it doesn't
good.
match that.
Excellent. So I'm glad that you're thinking about that. Now, the other thing I'd like you to think about is, we'll get back to the sun later, but the other thing I want you to think about is that those stars, like Sigma Octantis, and also, of course, the Southern Cross. If you are in South America and in South Africa, or if you are in South Africa and you are in Perth, it's dark at the same time. Therefore, you will be able to see Sigma Octantis, and you'll also be able to see the Southern Cross. Both of you at the same time, at exactly the same time, will see the Southern Cross appear to turn upside down. Now, this happens at exactly the same instant. In other words, you're both seeing the same thing happen at the same instant. You're now 135 degrees apart. How does that happen? You're looking in two different directions, 135 degrees apart. Are there more than two poles of rotation? Because if there are two, you can't be people 135 degrees looking in different directions can't be seeing the same one at the same time.
Well, that to me that would just be similar to like in the north, like let's say the Big Dipper. By the way, was someone else in this combo? Because I was away and then I popped in. I hope it's all right that I've been. I mean, were you in a conversation with someone else, or was it just kind of in the middle of a topic? Because I kind of came in. I'm just saying I didn't want to. If someone else was in the combo from before, feel free to jump in too. But because I just jumped in, I don't. Maybe I should have listened longer to hear what was going on. But I just responded to your question, and then we've been going. But that's all good either way. But if someone else wants to jump in, feel free. But I'll just say, yeah. So in the north, let's say somebody's in Canada and somebody else is in Russia, or even if you want to do 135, you could find two places that are 135 away, and they could both see the Big Dipper, let's say, at the same time. So that wouldn't really be that surprising because they're looking at the same place. They're basically triangulating whatever the Big Dipper is, or they're looking at the North Pole, and they're both doing that, and they're seeing the Big Dipper. So in the same way, if you were in South with two poles, if you're in South Africa or South America, you could see the southern rotation in the same time, the same way you could with the North.
I want you to think about that really carefully because that does not make the slightest bit of sense. All right, if they're 135 degrees apart, you must be looking at different things. All right. If you've got a road that's going that way and another road that's going that way and 135 degrees apart, you can't look down that road and see the same thing. That's just ridiculous. You know that.
Oh, no. Yeah, I'm not talking about a Gleason's AE map at all. So if you're familiar with some of the two-pole maps, the longitude lines converge to the South Pole from the equator, and they also converge from the equator to the North Pole. So they're converging in the similar way it does on a globe. In the south, they don't spread out. Now I know what you're talking about. If you're talking about that type thing, that you're looking in different directions, yeah, I totally agree. On an AE map, it doesn't work at all because you're looking in other directions, and I totally hear you. But what I'm referring to is in the north, all the longitude lines converge to the North Pole. I thought you meant 135 looking at the same pole, but now I get what you're saying if you're saying spread out. But I don't think the Gleason's map works with that. So I would actually agree with you on that point too. But on the two-pole layouts, the longitude lines from the equator going south, they converge to the South Pole. So you could both, the people in South Africa and South America, it would be no problem for them both to be looking at Sigma Octantis. It works on the dual pole. It does not work on the Gleason's AE map.
Gio, could I ask you a question? Excuse me. I just want to ask a clarifying question. This dual pole model, do you have like stars in the south circling around Octantis, and then you have another star pattern which is circling around Polaris, and those meet at the equator when they rotate?
That's what the celestial sphere is. You have the two star wheels, the north and the south. So yeah, there's that. That's all celestial.
The angular distance between the stars in the north and the south should change. They should get closer to one another and further away from another as they rotate up in the sky. That doesn't happen.
Are you talking about like the two star fields where they would converge and diverge?
Yes. Yeah.
Yeah.
And if you actually measure the angular separation between stars all over the sky, they never change. Well, like the stars in Orion belts move, less than 4 micro-arcsecond per year?
Yeah, the stars don't change relation in relation to each other. They don't change. However, the northern stars are diverting from the southern stars.
No, they don't.
So I'll say that again. Let me finish. Hold on. Let me finish what I'm saying. The stars in relation to themselves don't actually change or diverge from each other the way that that's why they're called the fixed stars. However, the northern stars are rotating around Polaris and the southern stars are rotating around Sigma Octantis. Even on a globe, the northern stars are rotating around Polaris and the southern stars are rotating around Sigma Octantis. Even on a globe, the northern stars are rotating around Polaris and the southern stars are rotating around Sigma Octantis. Even on a globe, the northern stars are rotating around Polaris and the southern stars are rotating around Sigma Octantis. Even on a globe, the northern stars are rotating around Polaris and the southern stars are rotating around Sigma Octantis. Even on a globe, the northern stars are rotating around Polaris and the southern stars are rotating around Sigma Octantis. Even on a globe, the northern stars are rotating around Polaris and the southern stars are rotating around Sigma Octantis. Even on a globe, the northern stars are rotating around Polaris and the southern stars are rotating around Sigma Octantis. Even on a globe, the northern stars are rotating around Polaris and the southern stars are rotating around Sig they're still diverging because latitude lines, like north of the equator, if you went west on, let's say, 10 degrees north, you would have to be turning to the right. So those stars also are essentially turning to the right, whereas the stars in the left, just like the sun arcs to the left and right. So yeah, the northern stars are diverting from the southern stars, even on the globe model, but they don't divert in relation to each other. They're fixed
No,
in their
no, they
relational
don't.
positions.
I'm sorry, Gio, they don't. The angular separation between the stars all over the sky is more or less constant.
Like this picture that Cole posted, and there's so many others, but he posted one that shows the two star
I don't
rotations. Yeah. So essentially, like the stars, like you see the right rotation, and then you see part of the left rotation. We'll see where that blends from the rotation on the right to the rotation on the left. See the middle point, that would be the equator. And look at how the stars on the left are verging off to the left. The right are verging off to the right. And you can see it with your own naked eye, and cameras pick it up, that the northern stars are diverting from the southern, but they're fixed in their relation to each other.
No, just go out and do the actual measurements and see the distance between the stars. That's an optical illusion you see in there. If you go out and you use proper equipment and you measure the angle of separation between, let's say, a star just north of the equator and one south of the equator, do that during the whole of the night, that angular separation will not change.
Okay, so can I get back to the sun now? Now, do you agree that the sun tracks the latitude in the northern summer, that it goes around the Tropic of Cancer? In the southern summer, it goes around the Tropic of Capricorn. Do you agree with that, at least?
Yep, absolutely.
Okay, okay, perfect. So the Tropic of Cancer. So this is essentially concentric circles around the North Pole, isn't it?
No, only for 6
On
months.
flat Earth.
Yep.
I'm talking about flat Earth.
If you're talking about the Gleason's AE map,
No. I'm
maybe?
talking about your version of it. Your version.
No, it only circles around the north for 6 months, and it circles around the south for the other 6 months. So it only does that for 6 months.
Yeah.
And then,
Okay. No, I'm not disputing that. And you agree that that is still the same distance wherever you are along the Tropic of Capricorn, or wherever you are along the Tropic of Cancer. You're the same distance away from the North Pole. You agree with that?
are you saying, is the equator the same distance to the North Pole as it is to the South Pole? If the equator's in the middle, or
No. I'm saying if let's say you're standing at 23.5 degrees, which is the Tropic of Cancer.
I've been there.
Anybody who's at that latitude will be the same distance to the North Pole. Do you agree with that much?
Yeah. Yeah.
Good. And anybody at the Tropic of Capricorn will also be the same distance to the North Pole. Do you agree with that much?
Not necessarily. They would all be the same distance from the South Pole.
No. I'm talking about the North Pole now. We're talking about the distance to the North Pole. Okay. So in other words, from the Tropic of Capricorn to the North Pole, it's I mean, you're looking at how many degrees? You're looking at 23 plus 90, aren't you? Right? That's how many degrees of latitude it is to the Tropic of Capricorn. All right, away from the North Pole, which, if the Earth is flat, is a flat distance all the way there. Okay, that's if the Earth is flat. So therefore, it follows that the Tropic of Capricorn must, for any version of flat Earth, go around the North Pole equidistant. Now, that's 23 degrees. What happens if we go out to 30 degrees? It'll still be the same distance for everybody around. What about if we go to 40? What about if we go to 60 degrees south? Still the same distance from the North Pole? How about we go to 90 degrees south? Still the same distance to the North Pole. Now, effectively, how is that different to any AE map?
Well, actually, that works. That actually works on if you're just talking about that, on a Gleason's map, even the AE Gleason's. I'm not asserting that or saying, and
I'm trying to work out how it works on your two pole model. How does that work on your model?
No, what I'm saying on the globe and the AE Gleason's, it would be the same distance from the Tropic of Cancer to the equator, technically, if the tropics were concentric circles.
How's yours different?
Because if you have two poles on a plane, then they're spread out.
There's two poles on a plane, but I'm talking about when we get to 23.4 degrees south. In other words, 90, and then we've got a bit further south. So 90 is at the equator. We go a bit further south, so we're more than 90 degrees away from the of latitude, away from the North Pole, and still everybody is the same distance away from the North Pole. We go a bit further than that, still the same. Bit further than that, still the same. We get to 90 degrees, still the same. So effectively, whether your map happens to have two poles, whether it happens to have just the North Pole, effectively those latitudes are still the same distance from the North Pole, which effectively, up until latitude at least up until 90 degrees, that's effectively the same as the Gleason map. How is it different? I'll let you have a think on that. I'll just finish my dinner.
Was that a question? What was that a question? Could you reformulate the question?
Yeah, that was a question. Yeah, I'll reformulate that again. All right. So you arrive at the equator. From the equator to the North Pole, for everybody, the distance is the same.
Yeah.
You go further south 10 degrees. For everybody, the distance is still the same. You go down to the Tropic of Capricorn. For everybody, the distance is still the same. Go further down to 60 degrees. Still, same distance to the North Pole. Go to 90 degrees. Still, same distance to the North Pole for everybody. This is the flat Earth. So what I'm saying is, at least until you reach 90 degrees, there is functionally no difference between your version, in other words, what you perceive as reality, compared to the AE map. There's functionally no difference, at least until you get to 90 degrees south. Okay? This is where the GP of Sigma Octantis is for at least one position on Earth. Of course, you've got a problem because 135 degrees, we've got two different positions. You can't now define a difference between the AE map and your version of the map, because this is the problem with flat Earth. You have one hypothesis, but you can't make that hypothesis congruent with another with another reality. That's the problem. So you can say, yes, there's two poles of rotation, and say, oh, that works really well because we've got converging longitudes, but that stuffs up another reality, and the sun is a typical example of that being stuffed up. That does not work, because the only way the sun works is if for your flat Earth, you've got to appreciate that the sun goes around the Tropic of Capricorn, the same distance from the North Pole for everybody. So if that's happening on flat Earth, there's no reason to suggest that it doesn't happen at 60 degrees, 90 degrees. You've got one great big circle at 90 degrees, all at the same distance from the North Pole. That's why it was reaching for the Gleason map for flat Earthers was so easy. It was a no-brainer. It had to be that, because those concentric circles or latitudes are a fact. We use them for navigation. My GPS system actually works. Whether I go to South Africa, whether I go to South America, whether I go even up to England or United States, my GPS works. I've actually taken them there. It works. It works exactly the same. So I can predict where I am exactly just by looking at my GPS, and there's my GPS location. This is where I am. You cannot have a different version than AE map, at least until 90. What happens after 90 degrees? You can make another hypothesis after that. But at least 90 degrees latitude south, It has to be the same as the Gleason map. Now, when I'm looking south and I'm looking towards the GP of Sigma Octantis, I'm looking at 135 degrees apart. In other words, down that road, I'm seeing the same object. Well, that's literally impossible. 135 degrees apart. You try that on a road, see if there's a building down there, turn, make a sweeping turn of 135 degrees and look down there and tell me if you can see the same building. If you can, you are a remarkable human being. So I just want you to have a bit of think of that because you can see that. Now the problem is here, you've made your flat earth the default. All of these problems that I've just outlined to you work perfectly on the globe Earth. Perfectly. Nothing is wrong. They fit together. It's like a glove. Nothing doesn't work. Nothing doesn't fit together perfectly on a globe. And yet here you are trying to make suggestions about the shape of the sky, the two pole rotation, maybe this, maybe that. All these maybes and ifs. Whereas there is a model where it actually does work perfectly.
Well, I wouldn't quite agree because
that's not your default.
I wouldn't agree because there is the dark matter problem. So gravity really doesn't work in the globe model. That's a whole component right there, which is a major factor of the way the sky works.
Gravity is my expertise. You come at me with gravity, I'll tell you anything that you want to do about gravity. Okay. Gravity is actually my area of expertise. Can we go with that?
No, I got you.
Tell me how you think gravity doesn't. Tell me how you think gravity doesn't work.
We got to let Gio finish. So when Gio goes speak his sentence, we got to let him finish. So.
Well, I was just mentioning a few things. I was saying the dark matter issue. I would say also there's issues with curvature. Obviously, not only the long distance observations, but just the lack of measurable curvature. I'm just saying I would contest a lot of these things. I don't know if we want to get into all of them. Because your argument was basically saying how you think that certain things work in perfectly with the globe. If you think it's a globe, that's fine. I mean, you can have your thought pattern, but you're obviously here talking to people who don't think it's a globe, or some who don't. So where do we go from there? I mean, I'm very familiar with the globe model.
I
contest many components of it, and I don't think it's even close to a perfect model of the entire cosmos, as it were. If I were to say that.
Forget the cosmos. I'm just talking about the Earth itself. Okay.
Well, I'm including the Earth in that, the whole thing, the Earth and the.
No. Let's just talk about the Earth up to the edge of our solar system, if you like. Okay, so the sun. Okay, so the Earth up to the sun, we'll call that the extent of what we're talking about. So the Earth is in there. Now you tell me, with a model that fits perfectly, nothing is wrong about it, and you
can't do that.
That's this model. And then you look at that other one where you've got, maybe this, maybe that. Could be this, could be that.
No, you can't.
Not sure about this, not sure about
that.
And you choose that model instead of the one where everything fits 100% perfectly.
You can't do that. You can't just use the solar system because we rely on the stars for navigation and to get our ground positions. So you have to include the stars, unfortunately.
I've already debunked the flat Earth notion with the stars. So I'm trying to be generous to you.
No, you can't. You can't just exclude the stars and just have the solar system. It's not possible. But you have to look at it as a whole.
That's fine. That makes it worse for flat Earth, not better. I'm trying to be generous. That makes it worse for flat Earth if I include the stars. Like I said before, you can't look down the road at make a 135 degree swing, look down another road over there and see the same building. That's not possible. Not even a flat earther could agree that you could do that. So that's not possible. The stars don't work for flat Earth. If they did, and you were looking at if you were looking at the Southern Cross and the Earth was flat, the Southern Cross would move horizontally across your field of view. It must do that.
Have you even seen any of the dual pole ideas?
Of course I have. Of course. total
So,
nonsense. Yeah.
so you do understand that, like when you are looking at the North Pole, for example, and you're going around the North Pole, it's the same distance as if it was on a globe.
I'm not worried about that. Of course, because that a line of latitude is 69 degrees apart. There's no question about that. I'm not arguing about that. But
You were
that's
saying the
it's
distances
69.
wouldn't work.
It's not the distance. It's not the distance on a flat Earth. It's a distance on a sphere, and I can prove that too.
You were saying going around the Capricorn and the Cancer, if you're going around, you're going to be the same distance away from the North Pole, and you can compare that until the 90th parallel south if you're on a Gleason's. But I would say because
No,
of your
you can compare it. You can compare it up to the equator, of course. And in fact, the distance from the North Pole to the South Pole would be the same distance as from the North Pole to the South Pole on a flat Earth map. That wouldn't make a difference. From the North Pole to the South to 90 degrees, which is the most southern, which on a flat Earth map would be the southernmost concentric circle latitude. You didn't actually, all of that stuff I explained about how at 0 degrees at the equator, everybody is the same distance from the North Pole. At 10 degrees south, that's another 10 degrees further, everybody is still the same degrees. 40 degrees, everybody's still there. From the Tropic of Capricorn, everybody is still the same distance from the North Pole. All the way to 90 degrees, everybody is still the same distance from the North Pole. Now, you've got to accept that there's no version of flat Earth that you could put that meets that reality, except the Gleason version of it. It's the only one that's possible. And that's why the Gleason one was the obvious one for flat earthers to adopt in the early days. To say that there's two poles, now perhaps you've got to think about the sun. The sun doesn't go around all the way. Maybe it's got a Pac-Man version of the sun where it reaches a certain longitude, disappears, and then reappears in the other west or east. In the east, I don't know, some sort of magic like that. Again, that if this, maybe that, could be this, could be that, and yet right over here is a model that's perfect, 100% faultless. Why would
if
you
it's so
choose
faultless,
the if, then, and maybe?
if it's so faultless, why are they up pretending that they're in space and floating around on wires? Why don't they just do it for real?
Nobody's doing that. That's your interpretation of photographic artifact. That's all it is. Okay, it's because you want to see what you want to see. These are just photographic artifacts. They are not. Those people actually are. There's no problem. You can't explain to me in any terms of physics why they can't be there. Why is it? Why doesn't that make sense? I mean, that works perfectly on a globe. On a globe model, of course, it would work. It can't work on a flat Earth because you would need energy. Where are you going to get the energy from? If you're one of the lucky people, you'll be able to look in the sky and you'll be able to see the Starlink satellites. Okay, you'll be able to actually see, and if you go to the NASA website, you'll be able to see exactly when the ISS is going to go above your head. This is a thing that's moving more than 10 times faster than any known fighter jet. At least 10 times faster than any known fighter jet. This thing is moving in the sky. All right. So you tell me, how does that thing keep going for 20, now it's 25 years? How does that manage to get me to remain in the sky for 25 years without needing fuel? Going more than 10 times faster than any fighter jet. How does that happen on flat Earth?
I'll tell you how it
I'd love
happens.
to know.
I'll give you an idea how it happens, and from many thousands upon thousands, whether or not you believe it's a ball or not, witnesses seeing what they would imagine to be some type of technology moving at extreme speeds, especially documents that have been produced from the American government and many governments around the world have eyewitness testimony from all levels of life talking about these unexplained UAPs, they call them. Like, there is something that can defy what we understand in this world, physics. So you can't just use that as like some authority that you can appeal to.
Oh, yes, I can. You see, because the ISS was built by humans. We humans don't have anything that without fuel, without applying energy, because that's physics, without applying energy, without fuel, can cause something to move more than 10 times faster than a known fighter jet. We humans can't do that. We can't defy the laws of physics. That would enable something to move that fast for so long without energy. Okay, that's not possible. So yes, of course I can. Maybe there's some alien craft with some technology that we don't know about, and they, because it's still physics, they still have to have energy. They get their energy from somewhere, maybe sunlight. Who knows? However, they manage to convert energy. They manage to stay around for a very long time and move very, very fast. Us humans, who made the ISS, bit by bit, it's documented over the now 25 years since it began. We humans made that. We humans are not that clever. We have not got something that can defy the laws of physics that says we can move an object that fast without fuel for 25 years. For 25 years in a circular motion, in literally in our atmosphere. That's
I think someone else was
impossible.
trying to get in. Like, someone else wanted to say something.
No, I honestly just couldn't bear to listen to a monologue anymore. I don't feel like engaging.
This 2026, so 2019 is when
like,
SpaceX
when do
launched
you think
Starlink satellite.
when do you think you're going to finally like get verification for yourself? Like, what's it going to take for you? You believe it's a globe, but like for ultimate verification, is it gonna? You have to wait until you die and go on the other side to look back down, or are you gonna, like, would you like, how would you verify this? Go up in a spaceship, and have you seen the globe yourself, like in reality?
Yes,
You
I
ever
have.
seen it?
Yes, I have.
How?
Yeah. So basically, I was working at the command center in Bangalore during at the time when they were launching Cartosat 3, which, by the way, is an Earth mapping satellite. Okay, so that's a whole nother thing that we can talk about. But all right, so when they're launching that, and I was also there when they were launching the Chandrayaan 3, the Chandrayaan 2, sorry. I was with the Chandrayaan 2, not Chandrayaan 3. Chandrayaan 3 was successful. Chandrayaan 2, unfortunately, crashed. So I was with Chandrayaan 2. When it was about 48,000 kilometers away from Earth, the camera, which I had some input into, turned just beautifully so that it faced the Earth, and looking at that, so right, let's take a picture. Let's snap a photograph of it. The camera's facing in the right direction. Bang, bing. Got beautiful pictures of the Earth from 48,000 kilometers. Absolutely magnificent. 100% a globe. No question about it. Couldn't get the whole lot from 48,000 all in one shot, but we got at least 70% of the Earth into the photograph from that beautifully. Not a problem at all. So yes, I have seen it. I have seen it through the vision of a camera. Yep, 100%. And this camera, I also knew that this camera was tested on the ground before it went up in the rocket. Okay, so it is the same camera. It's the same switch. We press the same buttons. We see the thing up there in view, comes into view as the spaceship goes around, because this spaceship took 42 days to get there, by the way. In concentric circles, and as it swung around just in exactly the right place, to say, right, okay, let's take the photograph. That is a beautiful photograph. In fact, the photograph is one of the photographs is a photograph of around the Baltic. The other one is a photograph of where Baja, California, is right dead center of this photograph. Absolutely beautiful. Happy to share that with anybody who wants to have a look at it. It's not something that you see often on the internet. I don't know why it never became that popular, but it is a wonderful photograph. I'm happy to share it with anybody. I have got that photograph, those photographs, and I guarantee you the Earth is a globe. I've got many other reasons to know it's a globe just based on measurements on Earth, let alone these actual photographs. Okay, look, it's nice to have these conversations and have the hypothesis: could this happen? Could that happen? Those are okay. We're having nice conversations. It's great. I love it. I'm not saying that you should not think the Earth isn't flat or whatever. You know, that's great. Let's have these conversations. It's good to share different hypotheses. I don't have a problem with that at all. But then to state this as a fact, that's another thing. Okay, so we know what the facts are, but it's nice to to suppose that it could be something else. Once we go out of our solar system, wow, that's another whole ball game again. Okay, so there's a lot of opportunity for conjecture out there that far. That's because we just don't have the tools to measure stuff that we need. Now, I know I'm
What exactly did you
monologuing,
work
but
on the you said the what? The Chandrayaan
Chandrayaan
2?
Chandrayaan 2, yeah.
Do you happen to have images from there?
Absolutely.
Personal images,
I
or just
actually
know
have.
where they're at?
No. I'm talking about knowing that the Chandrayaan 2 is actually orbiting the moon right now as we speak. So it's still in operation. But not the orbiter, the landing gear that was on Chandrayaan 2, which is Chandrayaan 2 is the orbiter. The landing the Vikrant orbiter that failed because they tried to land that on the moon, but around about it was probably about 500 meters away from the Earth. That's when the telemetry was lost, and therefore couldn't control the speed, and as a result of that, the thing crashed to the ground. So that was lost. But the actual orbiter is still there. The Chandrayaan 2 orbiter is still orbiting the moon right as we speak now. And yeah, there's not a lot of pictures because as the rocket is going around in these concentric circles, there's not many opportunities for the camera, which is a still camera that's fixed to the body of the payload. There's not many opportunities for it to swing by and see the Earth. So when it does, and you know that it's happening, then that's a great opportunity to take a really nice picture of the Earth, which we did.
So, can I ask a question? When they do get the orbiter or whatever in orbit around the moon, they need to slow it down. Do they use a combination of brittle rockets and the gravity of the moon itself?
Yeah, so the gravity of the moon is what causes it to orbit around the moon. All right, so that's what aids the orbiting around the moon. So the thing is going fast enough, so that gives it centripetal force in one direction, and then the gravity of the moon is opposite to that. So the orbiting happens as an equilibrium between gravitational field, causing it to want to head towards the ground, towards the moon, and the speed of it, which produces a force mv squared on r that allows when those two are at equilibrium, then the thing can just keep going. There's nothing to stop it. If it slows down,
I was thinking about. I suppose when it gets close to the moon, it has too high a speed to end up in orbit around the moon. Just the gravity. So they need to slow it down by rockets as well, don't they?
Yes, they do. Yeah, exactly.
Okay.
So they use rockets to slow it down. Yeah. So if you look, they use thrusters to slow it down, which is rocket technology. Really, you're throwing out what happens with a rocket. You're throwing out large amount of mass in a very short space of time. That's essentially a rocket. Okay, it's essentially a controlled explosion.
Yeah, I find it really fascinating that they actually can do these orbital mechanics calculations beforehand So not to know how much of the rockets they need to use in relation to the speed and the angle towards the moon and so on and so forth.
I have worked in as a physicist for a long time, and every time someone like you just says that, the hairs on my head, on my neck, stand on end when I think about Sir Isaac Newton, who gave us this. The smartest scientist who ever has lived, who will ever live.
Very likely, yeah.
That's gave us this, exactly what you just said.
And it works. I mean, we look at the other.
And it works.
Yeah, like when they send out the Voyagers, how they use the gravity of the different planets to change their trajectory, to speed them up, and so on and so forth. And these planets are moving at the same time. So, it's impressive.
You guys sound like zealot priests.
So you actually have right now. You actually have a physicist in here who works on rocket technology, who has firsthand dealt with rocket technology and satellites and sent them into orbit. You guys ought to be pounding him with questions about.
I'm trying to, but they like to monologue and like pat each other on the back.
Okay. If you want me to explain gravity and that, I'll be glad to do that, because that's obviously in my wheelhouse.
I just wanted to know what you worked on the Chandrayaan-2.
Insertion of the Chandrayaan-2 into its correct orbit was the main thing. That was.
So you were working on
I was a guess,
orbital velocity, escape velocity, etc. That kind of stuff.
Yeah, exactly. Making sure that's exactly right. Making sure that our insertion, because we predicted that it would take 42 days, and I can't remember exactly how many orbits that was going to take us. That had to be very, very precise in order for that to happen. None of this happens by accident or just that'll do. Right. The tolerances are very, very, very small.
You have to satisfy the parameterization of whatever simulator you're looking at.
Let me ask you a question. I want to ask you a couple questions, so just give me short answers, please. Just it'll make it simpler, and it's not a gotcha or anything. Don't worry about that.
That's okay.
So, was you involved in building the satellite?
No.
Or just writing the code to it?
No. That already. This I saw it in its infancy stages, of course, but no, not me. There's teams of others, engineers who are satellite builders and all that. The satellites take about 10 years in the development of it.
Yeah. So did you write the code to it, or did you just do the calculations so that they could then put it in the code?
Just checking to see that the code was right and matched the proper calculations. Yeah.
Okay, so then all I'm trying to figure out is if it's some kind of lie, where then does the change happen that the people who figure out what it's supposed to do and all the calculations that it's supposed to do, does that just get thrown out and they just don't launch it, or what? That's what I'm
looking at a screen.
Yeah, we're not just looking at a screen. We can that camera. That's the same camera. That's the same button that we have to press to activate that camera. That didn't change from the camera when it was being tested on Earth to the camera when it's up there. That didn't change at all. That rocket surely did go leave the pad. I guarantee it. Absolutely followed it all the way up into orbit. Even got some photographs of releasing the payload. So all of those are photographed. I'm not talking about we'll pretend that this happened or maybe this happened. We actually have photographs of it happening.
And you have telemetry data as well, I suppose.
So
we can actually see the fairings being blown apart. So because they're on exploding bolts, we can see the fairing come apart, and we can actually see the payload, and then we can actually see when the payload leaves the actual rocket and we can see when the rocket starts
Awesome.
falling
Can I-
away, being left behind.
I salute you, sir.
Can I get a little nerdy with you,
Go ahead.
Professor?
Yep.
So, in essence, I don't know how much you can talk about. You know what I mean? Because I know certain things are like,
Yeah.
you know, proprietary or
That's true.
intellectual.
Yeah.
But if you had to make an analogy in terms of like the software that you were using is similar to, etc., what exactly you were like? What, from 9 to 5, essentially, you're 9 to 5. What was your job essentially? And like, if you can give a rundown on like the software or like the software suite, maybe, or anything that will help me understand.
Making the right calculations, consulting on whether or not these calculations match the code and should match the code. What would we do in the event of some unknown, some untoward event that could happen? There's all sorts of parameters. What if this particular rocket doesn't fire? What if if that doesn't fire at exactly the right time? There's so many variables.
No, I know, I got you.
It's not just one person. It's a whole team. Yeah, it's just a whole team of people that are doing that. Yeah. When you look at a command center and you see hundreds of these terminals, you know, everybody's sitting behind you and think, well, why do they all need to look at a screen? They're all looking at different parameters. That's what they're looking at. They all have a different job to do. So each one of those persons is needed, and they have a different job. This one says you've got to monitor this particular process. You monitor that process. All of these things have to align. If they don't align and then align with the software, something's going to happen that's wrong. Something doesn't work. Then we now have to make proactive decisions about what we're going to do about it. Are we going to lose the mission, or can we make some adjustments?
That's my question, Professor. That's my question. What are you referencing? What are you all referencing to make sure you're on track?
Telemetry. In other words, the onboard sensors.
So telemetry data.
Yep. The onboard sensors, in other words.
Okay.
Yes.
Telemetry is a very broad term.
Do you guys do practice runs beforehand, before you do the actual final launch?
No, it's a very expensive thing to put. We've had lots of experience putting satellites into orbit, so we know how to get stuff into orbit.
No. What I'm saying is, you don't do any simulations or anything beforehand.
You do software simulations, of course you do.
That's what I'm saying. So
yeah.
So you're using the same kind of telemetry data for the simulations as you are for the real launch, right?
No. So a simulation it's no different to a simulation like you have a simulation of an aircraft, right? So going to, a pilot who's got to go into a simulator to simulate what happens if this happens, what happens if that happens, what do we do, how do we change, what parameters do we adjust, and so on. It's simulation that's what happens. You have to do that. If you you're not going to bank on spending hundreds of millions of dollars and not having at least worked out what are the possibilities, what are the things can go wrong, and what could you do about it.
Hey, no, I got you. I'm just trying to figure out if they were lying about what they were actually doing in terms of, let's say they just launched a rocket. You see the rocket, it goes and does its parabolic curve. You don't actually see it go out into orbit. So let's just take it from.
You do see it going to orbit.
No. I'm saying with the naked eye.
Well, what you see in the naked eye is you see the rocket's got a gimbal on it, so it makes it so it looks like it's going down. It looks like it went up, and now it's heading down. Well, that's normal. That's because the Earth is a globe. That should be instructive to you alone. Let me finish leave that alone.
My question. Yeah, well, I'm just saying, think about it from the other point of view, right? Let's just say that they aren't actually going, as high as they are claiming these satellites are going, right? And would there be any actual way to tell the difference between, telemetry data that is simulated versus real telemetry data? Is there certain factors that, like, okay, this is how I know this is real data? Like,
Yeah,
Anything like
absolutely.
that. Okay, what are
Because
they?
it's never exact to. Let's say we're working something to 4 or 5 or 6 significant figures, and sometimes more. It's never exact to those sort of things. So we always have some anomalies. They don't match exactly, right? So not
Yeah, of course.
to the exact, millionth of a second, right? So they don't. The simulator is a model, so it works purely on data. In real life, though, you get a different thing. Oh damn it, that explosion didn't happen. Not quite all the fuel got burnt, so the timing is not quite right. This thing,
That
a
RCS
part of the fuel
thruster's not.
got
That RCS
the
thruster's
thruster.
not putting out 100% like the rest of them
Yeah,
are. So you
exactly.
have
We
to
don't know.
adjust.
We don't know that till that's going to happen. So it's always going to be a bit different. And so we know that. Oh shit! Is that going to get over the hump? Because we got to get this thruster to work exactly
Based.
right. Oh no, that was a little bit too much. The simulator's a model, so it can't make mistakes.
But Beast, the question was,
You
can
have
we
to
measure the
you
height
have
of
to
satellites, right?
you have to cause it to make a mistake.
So you
Beast?
think you can remote control the rocket from Earth in space?
Beast.
Yeah, of
Was the
course.
question whether you can measure the height of satellites?
What? No.
Can you measure the
Ruhiv,
height of
hold on.
satellites?
Hold on, Ruhiv. Hold on. Let me talk to somebody else, please.
Okay.
No, not you, Professor. I want to pick your brain. While
Okay,
you're
no
here.
worries. I'm just going to finish eating my dinner, which has got cold now. So I'm going to mute for a little while. All right.
Okay, yeah. Go ahead and
Okay,
eat,
okay.
brother. I just have some questions. No, I'm not talking about the height of the satellite, Ruhiv. I'm just trying to figure out if there's an actual difference between what you would run in training simulation or like preparation event, like a rehearsal essentially, versus the real telemetry data that you're supposedly getting, the quote unquote real.
The real telemetry data could just be another data set with like variations in it. I don't really see how it proves anything.
I
But
agree.
The point is,
But
you
would-
can measure the height of a satellite.
wouldn't it be logical to use captured telemetry data so you could simulate a real life situation?
If you
Was
have
that just
pre-captured data, then why don't you just do it again in real life?
Yeah, I mean that's basically just assuming
No.
that you have the real life telemetry data.
No, but what I was trying to point out is if you want to create a situation, there must be times when you've recorded rockets with situations and then you would relay that back so people would understand what was going wrong. That sounds logic to me, but maybe not.
Yeah, of course. Also in the black box.
Yeah, exactly.
But
You wouldn't just make up things on the spot if it didn't, how would you even go about it? We'll just make up a simulation. It doesn't sound correct. That's kind of learning off your mistakes. Rule number one, I would imagine.
yeah, this photo just seems very suspect.
As in GoPro.
Planet America.
I'm trying to figure out what country. Oh, that is North America. Yeah, that's the tail end.
Yeah. But it's a GoPro, right?
So
A wide angle.
I'm trying to figure out right here. Hold on. I'm trying to figure out, is there a way to get the raw image of this from the ISRO? And you could essentially see what time that was posted.
Even that photo, I mean, assuming that is like a not malformed photo, America's way too big. It's taking up like a quarter of the globe.
Oh, it's
I
clearly
know.
wide angle shot, right?
Yeah.
Well, I don't know. It could be a composite. It could be just one image. I don't know. That's why I want to see the raw.
There are videos on the internet where people have taken a basketball and using a couple different settings on their camera and taken a picture of the Spalding word on the basketball and shown how one makes it look like the word Spalding is a quarter of the size, and the other, just using a different camera setting, makes it look like it's much smaller compared to the size of the ball. It's just the camera. Difference in cameras.
No, I can agree that probably is the case. But it also works in reverse too, you know?
Yeah, that only accounts for a certain amount of enlarging, and some of the stuff NASA's put out is beyond what can actually be replicated. So it's still actually problematic. Even though, yes, that effect can occur when you're zoomed in. There's one, I don't know if I have it saved or where I have it exactly, but where he takes an actual globe, like a toy globe, as it were, one that you would buy at the store, and he just zooms into it close and then zooms out of it. And yeah, you can definitely get it to look like one continent is like abnormally taking up, because you're not really technically seeing as much of the ball, even like in real life with an actual physical ball. You're not seeing as much of it. So it would be expected that part of that would be the case, because you're not really seeing half of it. You know, you're seeing less than that. And then you're also zoomed in, and there can be wide angle lens effects as well. But yeah, it can make it look abnormal. But the thing is, there's only an extent at which that effect actually happens in reality. And what I'm saying is that NASA and some of these go overboard. They go over that, meaning that they don't look genuine from what can actually be replicated. The amount of enlarging is what I'm saying.
What? How is this the gallery? Dude, wait till you see this, Geo.
Is this the Chandrayaan thing?
Yeah.
Chandrayaan.
Hey, what's up, guys?
Yeah, I think I've seen a few of those over the years, but if you dig up some ones I haven't seen, it'd be interesting to see what they got.
Dude, well, this is their gallery, their archived website.
Is that
And you try to click on the photo, and it's like a
Hey, Gio.
thumbnail.
Gio?
A little .gov here, a little
Hey,
India.
Gio.
What's up?
Gio?
Yo.
Can you hear me?
Yeah, I can hear you.
Yeah.
Your mic was
It's
a little
Julius.
bit muffled though. Go ahead.
It's Julius.
What's up, bro?
What are you guys doing? What are you guys talking about? What's the topic? What's the topic?
At the moment, dude, we're kind of looking at these satellite
Where's
photos.
Voice text one?
Yeah.
Live text one, yeah.
Okay, hold on.
Usually people just listen and find out.
Oh shit, bro! Back up. Sit down. Sit down, bro. What the fuck are you looking at? Did you guys see the moon? Kind of looks like Revelations dumping out some cups. What do you think?
Yeah. You need to chill, bro.
Day after tomorrow is today, right? The movie, The Day After Tomorrow is today.
All right, I'm just gonna mute him, Gio. Is that cool? You guys cool with that? Hey, Julius.
Yeah, there's like nothing in that gallery, videos or photos. That's wild.
I just want to.
Is that QApp?
Julius, are you kind of?
No.
Are you like? I don't know. Are you good? We're just kind of live streaming. We're just chilling. What? But yeah, man, it's good to hear from you.
I was just gonna temporarily mute him and be like, "Yo, just relax, bro. Like, we're just trying to figure out if these images are legit or not." Thank you, Gleam, by the way, for posting the original images.
Yeah, when I clicked on it, it shows like a collage. There's like a bunch of different ones.
I can't find the actual raw.
I mean, I do hear what Professor Phil was saying about like his involvement in that. That is interesting. I mean, I think like, would we agree that for them to be doing this deception, like there would have to be some interface between what is allowed to allegedly go to space, you know, on the always government approved crafts, ultimately the crafts that are actually claiming to put these things into quote unquote space, are not just regular civilians. Like you and I can't just throw one up there. So now you can build a thing and hand it off to them, and then they'll send it up there or claim they will, and then you get this data back. But would we agree that like for them to be actually falsifying or to be like be doing a deception there, like they would have had to basically have like a team that's like sending people back, you know, the people who even work on this stuff, they're actually sending them back data that is in some way like spoofed in a way, or it's like in some way false information or like simulated information that they're getting that they think is real, that they actually think is functioning like a globe would.
Well,
That's kind of what I was getting at before, is that we can measure the height of these things, so it validates the telemetry data.
okay. Check this out. I found the old school website.
Was that a good drink?
So many of these satellites are special satellites for particular purposes that have a particular job to do up there, and a lot of them are handed over to private companies. In other words, it's private money, nothing to do with government. Okay, so ordinary people who investing their money, invest in this, particularly like, for instance, the people who are doing mapping. You know, and they sell their things. Google Maps, for instance, there's various mapping companies that sell mapping data and sell this to transport companies, real estate agents, all those sort of people who use these satellites to be able to measure stuff on Earth and to see what's happening on Earth. So, for instance, you know, somebody rings me up and says, "Oh, would you like to have solar panel on your roof?" You know, I can't actually say, oh, I've already got that, because they've got a satellite image of my bloody roof. So they know that I haven't got one, and that's why they called me. All right, because they know they know I'm a candidate for it. So now, as soon as I put one up there, they're going to know that too. Now,
No one denies satellites.
I can't speak too much about the military, but the military put a lot of satellites up there. All right, for specific purposes. Actually, we do. We have satellites that monitor, that we use to monitor things that happen here in Australia, that happen on the ground. Well, they happen, those things, and sometimes those things happen without any knowledge of people on the ground. Oh, there's a fire over there, you know, up in Whoop Whoop.
I hope this goes
down. How do we know that there's fire in Whoop Whoop if nobody actually goes there? And then when they actually go there, they say, "Oh, God damn it, there is a fire up there."
Somebody wants to respond to you, Professor.
Yeah.
Yeah, you're good. You're fired up. It's fine. Have you been in here before, Professor?
I don't know. I think so. Yeah, probably one or two times. Yeah.
Okay.
Yeah. Anyway,
so
I just thought I'd throw that in.
So no one's denying the utility of a particular thing, like let's say satellite imagery, Starlink, etc. Right? But I'm not going to make a fallacy by saying, "Oh, just because it works, therefore it's true." You know what I mean?
What do you mean? That doesn't make a bit of sense. How can you say it works but it's not true?
It's called a pragmatic fallacy.
Okay.
I'll explain here. I'll give you an example.
It works, so I'm going with it.
If I explain to you that gas pressure is basically, you know, it consists of tiny little unicorns bouncing off each other, headbutting themselves in order to create the pressure, you know, that's building inside of the container. But they're invisible. You can't see them. But that's how it works. And we know it works because we can measure the gas pressure with a gauge, and we can get 14.7 psi here on the sea level. Like, you can claim that there's little tiny invisible unicorns that are bouncing off of each other, you know, headbutting each other, but that doesn't necessarily mean that that's exactly true, right? Just because something works or that we have a pragmatic function for something doesn't mean.
No, but I can falsify that.
Yeah,
I can falsify what you just said. So of course I know
They're
exactly
invisible.
what's in there.
Wait, I got a better
It doesn't matter
analogy.
if they're invisible.
Quick.
I'm a chemist. I started my career off as a chemist. I can tell you for an absolute fact. I can tell you what's in the what if you give me a guess what it is.
Oh, you started off as a chemist.
Yes.
Okay.
Uh,
Well, you wanted to get in? Go ahead, Sack Tapper.
yeah, just a easier analogy to get it across. It's like believing that washing your hands gets the evil spirits off, so that's why you don't get sick as much. And it works because you're cleaning yourself from bacteria or or viruses or whatever, but you're not actually getting rid of the invisible spirits on it. You think you understand what the mechanism behind it is, but you don't, and it's something else.
Yeah, but in essence, I understand what you're saying, Professor. Right? Like we use these things on a day to day, but that doesn't necessarily mean that you're getting the imagery from a satellite that's free falling in an orbit around the Earth in a, around space time that's curving. You know what I mean? Falling in a
So
geodesic rather than, you know what I mean? Like there's so many different
yeah,
claims about that.
I get what you're saying. So tell me, why do you think it's not happening? Because you obviously don't want to. You want to adopt an if maybe this, maybe that, could be this, could be that model. You tell me, why do you think we couldn't have satellites doing exactly what I said?
Well, it's the mechanism of, a satellite is free falling in a geodesic, of curved space time.
Why is that a problem?
Because there's no way to prove that.
But it's happening.
How do you know?
You may not have the tools to prove it, but it's still happening.
How do you know that's true?
Well, I can measure the distance to the satellite. In fact, do measure the distance. The telemetry from the satellite tells us how fast it is. We know from orbital mechanics we can work that out. So T is part of the equation in orbital. So we can make T the subject of the equation. So we can work out. Sorry, the radius is the part of the. It's that. So we can make the radius here. Yeah, we can use physical things like laser ranging, or we can use radar. That's often used.
It's all light,
and the
right?
other thing is, and the other thing is, but the main thing is the telemetry that's on the software that's on the actual satellites is using, and that's reporting back its thing is using orbital mechanics to do that.
Could one say that, like the calculation? Excuse me. Could one say that the let's say the calculation done beforehand is sort of a hypothesis, and then you actually send out the satellite, and you see if it behaves like you're hypothesized beforehand?
Yeah, so back in the early days, the hypothesis was that looking at the gravitational field strength, looking at Newton's law, universal laws of gravity, and saying, well, okay, well, we can test this. So to test that to see if it's true, then we'll make this particular hypothesis about what would happen if we did put a satellite. In other words, we technically should be able to do it if Newton is right and all the other things are. So Newton's circular motion is right, and if Newton's gravitational is right, then and those two forces we can reach an equilibrium with those two forces. Then technically, this thing, if it's going fast enough and at the right altitude, should orbit the Earth. Okay, so we'll look at that and we'll say, well, that's what should happen. And then we say, well, that's the hypothesis. Okay, so let's test this out. So we'll put something up there, make sure it goes fast enough. If it doesn't go fast enough, then it should just come straight back down to the ground. We've put it up, make it go fast enough. Oh, it's not coming back down to the ground. And it's maintaining an orbital distance away from Earth. And we can see what that distance is. We can measure it. So now we say, right, oh, shit, this orbital stuff, that actually works. Let's see if we can make some money out of it. That's why there's 6,000 of them up there now.
1 second, Professor. Okay. I know, trust me, there's a lot more, like we definitely, there's a lot of people in here that understand the concept. But you asked me, you said, why am I so opposed to, a satellite free falling in a geodesic of space-time curvature, right?
Yeah, sure.
What was the concept before that, before Einstein?
Well, we didn't have satellites before that, but before that, nobody actually understood why gravity does what it does. Why is there a gravitational field? What caused the gravitational field in the first place? So everybody knew that there was a gravitational field. Newton knew that there was a gravitational field, but Newton didn't know why, didn't understand why. All of Newton's laws, make sure that's a law, eh? All of Newton's laws are governed around the fact that this is what happens under these conditions. In other words, Newton told us what gravity does. But Newton had no way of knowing why it does it.
Yeah, he compared
That's the issue. And
anybody
this is
that
where
was trying to
Einstein came
answer that
along.
to. Well,
This is what Einstein came along and said, well, this is ridiculous. We've got to find out why it does it.
Well, no, you're skipping a
And
part. You're
what
skipping a
part?
very important part. Well, there was people
Mhm.
that had a totally different conception, even from Newton, which was about the luminiferous ether.
Newton also proposed it. He denied the idea of instantaneous action at a distance.
Yep.
Because he didn't
Yeah.
have the understanding of general relativity.
No.
Exactly.
Let's before we skip to general relativity, let's talk about what happened right before that, because that's a very pivotal moment in history, essentially. Because for 100 years, we basically we haven't went anywhere in terms of like inventions since like Maxwell and Heaviside and Tesla. Those are like the last really big brains of the century that actually got us to, useful things like the
I'm a
electric
big
grid.
brain.
I mean, you could say that, all right, now we have rockets and et cetera, but like in terms of, energy and physics down here on Earth where it matters, like, why do people just completely gloss over the fact that Michelson Morley and Dayton Miller and Michelson Gale Pierce and all these, different experiments trying to prove that the Earth was orbiting around the sun at 30 kilometers a second, they failed to do so. And so then
That's not what they were
why,
trying to do.
yeah, they were trying to measure 30 kilometers a second, right? The orbit of the sun, the orbit of Earth around the sun, right? That's going through a static luminiferous ether. They didn't measure it. They only measured 6 kilometers a second, which is more than a null, but they said it was a null. And then to explain the lack of motion that was measured, this is where Einstein came with space-time curvature and general relativity or special relativity, essentially. So
I know
explain
that's
the idea. Huh?
Yeah, that's the flat Earth rhetoric, which is totally misunderstood the whole thing.
I have the papers.
So basically, what happened was during the time of Newton, because Newton also, this guy was just to say was phenomenal is just so understating. Because he gave us the
You're a fan of
calculus,
Newton?
for God's sake.
Like a really big fan? Have you
duh.
heard of his second
Okay.
his second theory on the mechanistic explanation of gravity from his paper of on the vegetation of metals?
I'm satisfied with what Newton did. Thanks very much. But
This is from Newton.
yeah.
Yeah, your guy.
Yeah. So I'm just trying to tell you what Newton not only gave us the laws of gravity because through all of those measurements and stuff like that he's managed to do, but then gave us the calculus because he needed the calculus in order to accurately do the stuff that he had to do. So we've benefited from that. We've benefited from kinematics. We've benefited, and not only that, also light. So there was this thing about waves. All right. So well, okay, we've got radio waves. We've got photons from radio all the way to gamma rays and X-rays and the like. These are all photons. And we're saying, well, okay, if water
if sound requires a medium to travel through, in other words, for that energy, then why shouldn't light do that?
Yeah, what's it waving
Okay.
through?
Yeah, and we're saying, yeah, exactly. We're saying, well, surely there's a medium for that as well, because you'd expect it to there to be one. But the way that what they had to measure it with wasn't good enough to be able to detect. So I'm not saying that there isn't an ether. I'm not even saying that there isn't. I'm just saying that there isn't any evidence for it. I'm not
There's no
saying there
evidence
isn't.
for gravitons or virtual photons to explain electricity and magnetism.
Well, there
Where's your
is.
evidence for that?
Yeah, there is evidence for that because
How do you measure a graviton?
Okay, well,
nobody really believes there is a graviton.
We measure gravitational waves. Okay, so again, this is all at the theory stage. All right, this isn't the level at which you and I would approach gravity or would need to use gravity. Okay, so this is a lot of that is still in the theoretical stage.
Or not though. Hold on, wait. Do you think that gravitons have been proven and are real? Yes or no? So we can move on from that.
I don't know.
Okay, that's fair enough.
What do you think? Do you think gravitons, in your opinion, do you think that a graviton will be discovered, or
no?
Are you just completely
I personally don't, because I think that I go along with at this stage I'm going along with Einstein and saying that it's nothing to do with that. It's all to do with how space is bent and all that. So I don't think it's likely that's likely to be a thing. It's a nice, just like string theory and all that. It's just like this, just like Fado. It's a nice thing to talk about. All right, but then I don't believe it that they'll come across gravitons. But
I agree,
there you
Professor.
go.
Yeah, but Einstein goes out the window when you have relative simultaneity. The two trains. You know what I'm talking about?
No, nonsense. It doesn't go out the window. And the reason that it doesn't,
because if you actually have a real world example, like a bomb, let's say there's a bomb, right? If there's a real world implication of when that bomb goes off, then there is an absolute frame of reference. It can't just be relative, because you actually have real world consequences, which is exactly how we do everything in the first place. Everything is in the lab frame. All of our kinematics, all of our dynamics, all of your orbital velocity calculations, everything has to treat Earth as stationary, as a lab frame.
Of course. Yeah, it does. It treats Earth as the lab frame. We're talking about stuff that's local to the Earth. We're not talking about if you're away from the Earth. That's quite different.
Have you been away from the Earth, Professor?
Well, not personally, but equipment
not.
that has. And I have ways of using the equipment to know what's happening on the Earth, of course.
You get my point, though, Professor, right? Like, there is.
No, I'm not. You're trying to use the slightest little thing, any little hair, let alone straw, any little hair you can grip onto to just hang on to this idea when you know for an absolute fact that here you have one model that explains everything beautifully.
No, it doesn't.
100%. And over here, you've got one model is just maybe this could be that.
I wouldn't even say I'm a flat earther, because that would be another fallacy. That would be another fallacy to claim that I know the entirety of something without actually having to measure it.
Well,
I don't know what's at the north. I don't know what's at the South Pole, the North Pole. I have no idea. So for me to make a claim about that,
why don't you have an idea? Why don't you have an idea? You're incapable of doing research? Why do you have to go there to know that something exists? Have you been to the North Pole? You think the North Pole doesn't exist?
I didn't say that.
Well?
I'm just saying, what I'm saying is, Professor, is that I don't take just things for granted, right? Like cool story about us sending a Voyager trillions of miles away, and then it's still sending pictures. Like, cool story. Like, these are all great stories. Like, if you're part of the fan fiction, like, I used to be an astrophysics nerd, obsessed with, Michio Kaku and Neil deGrasse Tyson and Carl Sagan and Carl Strauss and all of these people, and I used to absorb all of this information like it was water. So I know where you're coming from. I get it. I totally get it. But when you actually peel back the layers of how do they know what they know, it's insane. It's dog shit. No offense.
No, it's not. It's not. In fact, these people stake their reputation on stuff that like this. There's not a chance it's
They
dog.
have to. I mean, if you made a
No.
whole career out of it, I understand the underpinning of you made your entire career, not you, like the general you,
Yeah.
of people making their
Yeah.
entire career off of it. Like, imagine if you were working in something for 20 years, and then you find out that like it's bullshit. You know, you have two ways of going about it after that. You can either have cognitive dissonance, oh, it's not true, you know, I'm just going to move on and ignore it, or you address it. And if you address it, then you have to make a decision. Do I continue to lie to myself and to other people about what I'm doing, or do I go against the system that basically established me in the first place? And there's
All
people
right,
like that, like Dr. Robert Bennett.
I can
You
answer that.
consider
For
the
you.
possibility that it may be real?
Yeah.
I can answer that. I can answer what you just said about that. Okay, so I am one of those people who actually disseminate the information. In other words, involved in creating the data and involved in creating the information. So you've got to be putting me right there on top of the totem pole of this lie. Okay, that's what you've got to be able. That's what you have to do. You have to.
You know,
Yeah,
I don't mean any
I'm the one
disrespect to you
inventing this thing.
personally.
There's nobody around me. There's nobody around me that I can think of who can lie to me. There's no engineer that I can think of who can lie to me because I know too much. Okay, you can't lie to me.
I would love to pick
You
your
can't
brain.
lie to me. You can't lie to Ruhif. Okay, we know too much. We will spot any lie that you think you can come up with.
I'm
Right,
not
you
trying
can't
to lie
do that.
You're talking about computerizing math and stuff like that. Like I could lie to you and tell you I wrecked my vehicle yesterday and you would not know. But that's not what you're talking about. You're talking
That's not what
about-
I'm talking about.
Okay.
Exactly.
Just clearing that up, because if I don't clear that up, somebody will say
I
it.
want to extend an olive branch, Professor, but I know you understand the skeptic's point of view. Now, that being said, I am not unwilling to look at new information and just be like, nuh-uh. So there's a lot of things that I will say that to based off of the methodology that information was gathered from. You know, I will say, but wouldn't it be, according to you, wouldn't it be possible to have a concept of at least Earth being geostatic, like not moving, as the ultimate reference frame? And kinematically, that would be fine, correct?
Yeah, look, we use that. If I'm doing something like projectile motion that and all I want to do is hit something that's 5 miles away, okay, then I suppose I would take Coriolis into effect depending on the direction that I was going to shoot this
really.
projectile. But you know, it depends on how far. It depends on how on the time, the distance that it is, the conditions, the weather conditions, and all that. Whether Coriolis would make any difference at all. But so if I'm building a model for that, then I would probably build a model not without having Coriolis. So in other words, I would make an assumption that the Earth was still, okay, in order to make that model. Now, in reality,
easier, right?
Yeah, exactly. The calculations would be a hell of a lot easier. I could even model the thing as flat if it's a very short distance. Again,
I'm with you.
Yeah, in that case, that's because the calculations are very, very easy. And the difference between the proper calculation, if I did involve the sphericity of Earth, if I did involve the rotation of Earth, the difference is so small, it's not worth the work that's involved in getting to that precision. In other words, why do I? It's a bit like this. If I'm putting up a building, and I say that building is 100 meters wide, for instance, and somebody measures it and says, oh, that's bullshit. It's 100 meters wide and 1 millimeter. You know, you'd look at that person. You'd be a damn fool, wouldn't you? If you said it's not. I say it's 100 meters wide. That's fine. Someone comes up and says, well, it's not. It's 100 meters wide and 1 millimeter.
So
You know,
if it's negligible,
it's like that. I don't care. I used the Earth as though it was flat in order to build
stationary.
this 100-meter structure, right?
Cool.
And it turns out it's a millimeter off. So what? I'm still wouldn't.
I'm with you.
I still wouldn't try to measure. I wouldn't try to measure the thing as 100 meters and 1 millimeter. Because I'm using the sphericity of Earth, taking that into account. In fact, my instrument wouldn't be able to measure to that kind of
I'm
thing.
100% with you, Professor. Keep going.
Okay. No, that's it. That's the point I'm making, and that's why
Basically just made the argument
we do
for
make
flat
a
Earth.
stationary reference, and that's why we do make flat references for that reason, but not because the actual thing is flat or that. I mean, because it's provably a globe. There's no question about that.
But you just said it's negligible, and
No,
that you
but it's
wouldn't actually
no, the
use
whole thing.
sphericity in your calculations because it would be
I
too
wouldn't
hard
over
or
a short
complicated,
distance.
and that you would treat the Earth as flat and stationary in order to make your life easier, and that is
Yeah,
actually, and it works.
over
Welcome
a
to
short
Flat Earth,
distance.
Professor Phil.
No, absolutely not. Over a short distance. Don't forget that little qualifier. Over a short distance, over
Every
100
measurement
meters.
you do is going to be over a short distance or in your local vicinity. How
No,
can you
it's
measure
not.
anything without being in your local vicinity?
Because I want to go from here to New York. It's not going to be a short distance.
Well, how would you measure that?
I'm definitely going to be worried about the sphericity of Earth if I'm trying to measure the distance between here and New York.
Okay, how would you measure the distance between here and New York, or
Oh
here,
well,
where's here for you?
I could fly there.
Oh, okay.
Okay, that's one way. The other way is I can
You're flying.
well,
Now, what is
let's
the plane
say for instance I'm at Melbourne Airport, and LaGuardia is the other airport I want to know the distance between those two airports. Just give me the GPS location of Melbourne, the GPS coordinates of LaGuardia, and I will tell you the distance exactly. Now that I'm going to need the Earth's sphericity to do that.
No, you're not.
There's no chance I can do that flat.
No,
it's impossible to do it flat.
you don't use
I
the
will
Earth's
have to.
sphericity.
Yes, I will. Of
No,
course,
you're
I'll have to
using
use
the stars. Are you using
No.
latitude and longitude?
Listen back to what I just said. If I've got the coordinates here,
What are
and
coordinates?
I've got the GPS coordinates. I've got the GPS
Latitude and
coordinates.
longitude, right?
Yep, I've got the
And
GPS
that's
coordinates
based off
here.
the stars.
My GPS. I said GPS. Okay, so I got my GPS coordinates over here, which is latitude and longitude. I've got my GPS coordinates over there at LaGuardia, which is also latitude and longitude. I can now work out exactly the distance between these two places. I can work exactly the distance. But in order for me to work out the exact distance between these two places, I have to use spherical geometry. I have to use the sphericity of the Earth. That will not work if I try to do it, assuming that the Earth is flat. It will not work. The only way.
Yeah. Professor, excuse me, Professor. Could one also use the ECEF coordinates from GPS, X, Y, and Z?
Well, it doesn't matter whether you use X, Y, and Z. You're still going to need the radius of the Earth.
Yeah, that's what I mean. Because then you would just have two points in space, and the distance between those 2 points, well, if a straight line would be much shorter than following the curve of the Earth.
Yeah, but you're not going through the Earth. You've got to go over you got to go over the surface of it. All right.
Yeah, that's what I mean.
Yeah. So you're going to, no matter what you do, you're going to need to know the radius of the Earth.
The radius of the Earth is cooked into the celestial sphere model. I get it.
It doesn't work if it's flat. If I can't assume that the Earth is flat and use those 2 points to get the distance across, that will not work.
But
That's
how are
impossible.
you verifying the 2 points? Latitude and longitude, correct?
Yep, that's my GPS gives me the latitude and longitude over here, longitude over there, or X, Y, Z.
What is latitude and longitude based off of?
Well,
it's the graticule, right?
No, I mean,
Yes.
it's they certainly join together beautifully. Yes, I agree with that.
Aha. So
But
you're making
yeah,
so you're making a reification fallacy, thinking that the
no,
celestial sphere
No, beast.
means that the
No.
Earth is a
oh,
sphere.
nice. They join together beautifully. The gravity, the changing weight of something because of where it is on the Earth tells me that
We
it's got to
we
be
gotta
a sphere.
squash this fucking Gradical shit, Phil. Beast. Right, we both know that the meter was derived by the meridian arc measurement through
Right.
Paris, right?
Yes.
From the stars. But at the
Derived.
end, what did we get? We got a physical length called a meter, right?
And
Yep,
how much
right.
did they measure actually in reality?
Oh, can't remember.
2 kilometers.
7 or 8 degrees, something like that. Whatever.
2 kilometers.
What? 2 kilometers?
That's it. And then the rest was calculated.
What?
Yes.
Oh, hang on. You're talking about the
Paper.
one base of a triangle.
No, I'm talking
You're talking
about,
about one
where the
leg of a
meter
triangle,
came
right?
from. How it
Yeah,
comes
you're
to
talking about a
meridian.
triangulation survey, right?
Uh-huh.
Right. So they measure one base leg and then work out the
And then
rest. Sure.
calculated the entire thing after that. Yes.
Right. Triangles. Right. But they did it over like 7 or 8 degrees, whatever it was. But at the end, right, we got a physical length of something, right? If I go out into the fucking bush and I pick up a stick, right, the same length as that thing that we got, right, how many of those stick lengths are between Melbourne and LaGuardia? Right, once you've derived the length, it's now divorced from how it was derived.
Once you have the length, it's now what is that? I'm trying to understand what that means.
Right.
You have the length.
On a sphere, sphere, the number of stick lengths between A and B will be different on a sphere compared to on the flat Earth between A and B. There'll be a different number of sticks.
Yeah, that's for both. That's for both conceptions, because you're not actually on a perfect
So
sphere.
which one matches? Which one matches reality?
Yeah, but you're not on a perfect sphere. You agree?
Sure. Yep.
Okay, so there's differences, correct?
Right. Which one is like 99.9% correct?
So you have a conceptual model, right?
Right.
A perfect sphere.
Oh, no, Vincenti uses an oblate spheroid.
Okay, well, whether it be an oblate spheroid with a little bulge, in between certain latitudes by the equator, I can't remember exactly. But whether you use that or not, it doesn't matter. My point is, you're using a concept. It's just a conceptual model. This conceptual model.
Does it match reality or not?
No, reality
Yes,
is reality.
it does.
No, reality is reality. We make
So if I
concepts
predict
based off of reality, but that concept is not 100% reality. Even Professor Phil said it. He just said it. I'm not going to actually make a proper calculation, because to make a proper calculation would be insane. It'd be insane to get to that accurate, right? And I agree with
if
that.
I work out the distance between A and B, and in one case I use a sphere for a prediction, and the other case I use a flat Earth, all right, and the actual distance that I travel in reality matches the sphere calculation.
We have the dimensions of a sphere. What are the dimensions of a flat Earth before you just say that?
Oh, whatever flat Earth you would like.
Yeah, but what? What are you're comparing it to
A
something.
map, dual
I don't
pole.
know.
Of course you don't know, because you can't commit to a claim because you're a fucking
I don't have
coward.
the model. It's not about
Exactly.
being a coward. It's about, if I were to make a map of reality, right, I would have to use the stars.
Okay.
Period. Because that's the
So
only
you
known
have an
actual reference
almanac.
point. Yeah.
You have an almanac that tells you where the stars are at any point in time.
Mm-hmm.
Okay, where's your map?
What do you mean?
You said you would use the stars, right? You know where the stars are at any point in time.
Uh-huh.
Where's your map?
Yeah, I can literally take any map that uses the stars. Literally.
Okay.
If they're all
Show me one.
equivalent. You agree, right?
No, they're not. No, they're not equivalent.
Yes, they are. They have
It is
scales.
a different, right? It is a different number of sticks, right, on a sphere compared to any flat Earth.
What? What do you mean any flat
Any
Earth?
flat map. Yes.
No, incorrect.
Yes.
Incorrect. You can even have a 1-to-1 scale like the UK map. That's square. That's a grid.
They're not square. They're not
So
squares. They're not rectangular. They're, what are they called? Trapezoidal.
Okay, well,
Same with your freaking
I'm not gonna have this argument.
UTM.
But you know this is true. What is that to you?
Yeah, they're not squares in reality. Go and find the dimensions of one of those squares.
Thank you.
What are they?
It's not a sphere in reality. Exactly my point.
No, they're not squares.
What are they?
They're trapezoids. Is that the right word?
I thought you said crapazoids.
Trapezoids.
Yes,
they're shorter at the top
trapezoids,
than they are at the bottom because lines of longitude converge at the poles. They're not rectangular or square.
We can skip past this point, okay? Because we both know they're equivalent, Ruhif.
They're not equivalent.
Yeah. Yes. It's just dude. Any map that I make that uses the stars is going to be equivalent. Otherwise, it wouldn't be a useful map. Yes, it has to follow the same.
The disconnect in y'all's conversation is how you're measuring distances. You're saying each stick, the stick is measured using latitude and longitude, right?
No,
is that wrong?
However we derive the stick,
nautical miles.
however we derive the meter, at the end of it, we have a physical length of something. 4 of my cocks, right?
Not in like practice. Like if you're in a boat and you're traveling, you're measuring in nautical miles. You're not measuring in meter sticks.
But it's inverted.
Okay. What?
Either way,
You have an inverted cock.
That's not the main point. The main point is that you are equivocating the spherical coordinate system called the graticule, celestial sphere, whatever, to Earth. That's what you're doing. And you're like, well, it works beautifully. It works perfectly.
It does.
It doesn't. You wouldn't
Yes,
have
it does.
different
Give me a
ellipsoidal
distance
models
that
then.
doesn't match. Give me a distance that doesn't match reality.
Give you a distance that doesn't match reality.
Yeah.
Is that even a real question?
Yes. Give me 2 places on Earth, all right, where the distance calculated using a sphere is some margin of error different to the calculation.
Different compared to
the spherical calculation.
You see why that's like it's a weird question, Ruhif? I'm really trying to answer it, but I don't think it's a real question. How can I compare
Sydney to
2 different
Santiago?
distances?
All right, Sydney to Santiago is 7,000 miles, something like that, all right? And it takes on average 13 hours or whatever, all right? So we can get an approximate
we know
distance
that?
using that, right? How do we know that it takes 13 hours?
Yeah. How do we know it's 7,000 miles away? And it takes 13
No,
hours.
that's the
to fly
calculation.
back?
That's the calculation, right? That's the prediction is 7,000 miles. So how do we test it in reality? Take flights.
Okay, and then you take a flight. Now, how is
Yeah.
this plane accounting for distance over time?
Right, it has an airspeed.
Okay.
And they know their airspeed.
Okay, now how do you
So
know
you
what
average the
position the
flights.
airplane is in reference to the ground that it's flying over?
Right, we can track it
With what?
with ADS-B.
Okay. And then that refers to ADF. What'd you say? AF.
ADS-B. ADS-B.
Okay.
It tells us where it is. So we know where it goes.
Okay, it's a receiver. It's just a receiver. I never actually heard of this.
ADS-B is what flight trackers and flight radars work on.
Let's see, lateration.
What? No.
It's relying on GPS.
Yes.
Okay, well that's still based off of the coordinate system, dude. So yeah,
That's
okay,
fine.
obviously.
You ask where does it go? Yes,
How do
it
I
gives
know
you the
what ruler
GPS
is as long
coordinates
as a
of where it
ruler
is.
is?
Right. Fuck.
That's
Like
the
I
question
said,
you're asking.
we
How do I
both
know
agree.
a ruler is 12 inches?
No, we both agree that the meter was derived from the meridian arc, right? But we get a physical measurement at the end. How many of those physical measurements between Sydney and Santiago? How many feet between Sydney and Santiago, if you like?
Yeah, but if you're ignoring its point that it's still going to be derived from like how your GPS is changing, right? Which isn't measuring with a measure stick. That's measuring with relation to the star.
Right. We're trying to get an estimate of the distance based on the time. Right. He asked which route does it go, and I said because we get GPS, we know which way it goes. We're trying to get an estimate of the distance based on the time and the speed of the aircraft.
You need an ultimate reference point, though, to know how far you've traveled.
We can estimate it based on the time and the speed of the aircraft. That gives us a distance, right?
Okay, over what?
What do you mean over what?
Okay, so let's just pretend that we don't have any maps or anything like that. We just have a plane. That's all we have.
Yep.
Now we start off in Sydney, right? We're going to Santiago or vice versa, whatever you want to start. Okay.
Yep.
How do I know how far I've traveled?
Because you know the fucking time and the speed of the plane.
How do you know your speed if you don't know the distance?
Yeah, exactly.
The speed is airspeed.
Distance.
The speed is airspeed, right? And if you average both legs, then you do a good job of cancelling out any wind.
No. How do I know the distance?
Speed, time.
Okay. How do I know how far I've traveled?
Oh, Jesus Christ.
If I'm over
what
water,
is speed based?
This is important. If I'm over water, right? I'm flying in a plane. I'm over water. Okay. Let's say I've been flying an hour over water.
Yep.
And I'm at
What's your
such and
airspeed?
such speed. Let's say 400 knots. Whatever.
Sure.
Okay. How do I know how far that is without referencing anything?
Right, because you've traveled at 400 knots airspeed. Right? So if you average it back the other direction, you do a reasonable job of cancelling out any effect of wind.
What? Dude, distance. How do I know how far I've traveled without referencing
Christ.
something? You know
Right,
the question.
speed.
You know the question.
400 nautical miles per hour. Right? So in 1 hour, how far have you travelled through the air?
Are you just trying to ask, how do you know how far a nautical mile is?
No. He's battling with just speed equals distance over time.
Yeah, you still have to have a reference. My point is, you still have to have a reference point in order to establish where you actually are. Right? The only way. No, the only way is stars, dude. Is where that's the only thing that we have reference to.
No, the air. You use the air because you're flying through the air.
At this time, can I make a point? Because it's really important to understand this. I used to work in an airport, right? And they have a thing called padded time. So if a flight takes, say, like 1 hour, 45 minutes, they might put it down as 2:15. That's why a lot of times you see flights which are delayed actually come in on time or before, arrive early. That's a standard thing.
I know if you're flying into like a headwind, your airspeed will read different than your
It's not
ground
nothing. It's not nothing about that.
I'm not
It's
talking to
inflated.
you. I'm talking to Ruhib. Who Ruhib's talking to. But I'm just saying, so you're saying you're using your airspeed, but it's what I'm saying is, wouldn't your airspeed maybe throw you off a little bit if you're just going by airspeed if you're not actually tracking? I'm trying to figure out what he's trying to say. He's trying to say that if you don't have a fixed object or a fixed something to determine, how far you've traveled, just traveling through the air, if you're going into a headwind, your airspeed may read 400 knots, but you may just barely be moving 50 knots across the ground.
Right. And what did I say to that, Beast?
You said that you average it back out.
Yes. Very good.
No, I got you, but it's still,
Cool.
you get my point though when it comes to needing a
No.
reference to actually know how far you've actually traveled in the air, especially over water.
The average trip forward and back is a very good approximation for the distance.
Yeah, but that approximation only works because we've done that before. If you did,
What
like
do you
I
mean?
said, if we didn't have any references, we're just a plane flying over water at a certain speed, right? We have no way to know how far anything is yet. You see what I'm
Yep.
saying? Like if you didn't have these things already put into place, how could one actually determine, where they're going, like how far they've gone from when they started? You see what I'm saying? And
You're like
how could I draw my own map?
discovering new lands with commercial aircraft. Is that what's happening here?
I'm just saying. This is the hypothetical. Because you asked
Well,
me,
that's not
where's
something we
my
do,
map?
would we?
No, I'm just saying, you said, where's my map? Okay. If I'm going to
Yeah.
start from scratch, this is what I'm saying. This would be my point. Like, how do I start from scratch without using the stars?
Yeah, flight times.
You say that.
Yes, yes, I do.
All right, I give up. That's all right.
Okay. You should be able to plot the continents on some sort of map just based on flight times. Why haven't you?
That's all right. Anyway,
I
Professor.
mean, I know why.
I would love to pick your brain later on about on gravity, because I heard that was your specialty, but I'll be a later time.
I mean, there's how many flights is there per day? 130,000 or so every
Something
day.
obscene, yeah.
Yeah, it should average out over time. The distances.
It does.
I mean, just the number of flights across the North Atlantic between Europe and the USA. I don't know how many flights there are per day, but
I wrote some code a while back, right, which actually looks at the NOAA Jetstream data, and sort of calculates based on the Jetstream data how long the flight should take, and I'm within like 10 or 15 minutes all the time.
Yeah, but with what I said, how can you discern that it takes this time if they're padding the flights for, like that is for delays and kind of stuff?
Well,
How would
that's
you
the
know?
expected time of arrival. That's not the
Yeah.
actual takeoff to landing time.
There is a time that they take off and a time that they land. That's recorded.
The ETA is what they're padding a little bit.
Okay.
So put this in a
how
video.
do you find that takeoff to land point? Where'd you find that?
Times. It's in the ADSB data.
The what data?
The ADSB tells you their lat, long, elevation, or altitude, ground speed, airspeed, blah, blah, blah. In fact, I've got a raw dump here of ADSB somewhere.
It's funny, isn't it? They've only done that recently. They've put the ground speed and the airspeed because they're different.
they are because of wind, of course.
I share my screen. 1 sec. 1 second.
I got it.
This is some data that I've got. 2024. Yes, I've got all these planes going overhead. That's Jetstar 753. Yeah, this is just raw stuff. Virgin. Yeah, 38,000 feet. So it gives you all this stuff. There you go. Boom.
Yeah, but it's going to be using GPS, no?
Right.
Yeah, so it's
And these people have a problem with it for some reason.
already assuming that you're on a globe.
No, it doesn't. Is it possible to have a flat Earth like the AE map where each point has latitude and longitude coordinates? The answer is yes. I mean, it's up to you guys if you want to say that the fact that we use latitude and longitude means we're on a sphere. I'm okay with that.
If you're using Latin long, you're basically referring to the graticule, the celestial sphere. Even the AE map is just a projection of that.
Okay, so it's not the flat Earth map then. It's not equivalent. It's not equivalent.
It is. Do you think you draw straight lines on the AE map?
What? If that's what the Earth looks like.
Do you think you draw straight lines on the AE map, yes or no?
If you think the Earth looks like that, then that is the shortest. If you think the Earth looks like that, then yes, you would draw a straight line between A and B as the shortest distance.
You wouldn't.
Yes, you would.
You're already using the map wrong. No. Already using the map wrong.
What? How is the shortest path not the straight line between 2 points?
You're supposed to draw an arc length between 2 points with the 2 sticks that are coming out from the center of the AE map. Okay, so when flat earthers like to draw straight lines on the AE map, they're actually using it incorrectly.
Right. So why would you do that if that's not what you think the Earth is?
Yeah.
Who's you?
The reason you got arcs on a flat map is because it's a globe flattened to a flat map.
Okay, well if you guys know that, then what are we arguing about?
Because you guys can't have a map.
What do you mean we can't
the
have
only
a
map that works is a globe.
Dude,
the only undistorted map.
Like I said, you're saying the only map that works is the globe. The globe is not the globe. It's just the celestial sphere. What? You're saying the Earth is the celestial sphere. You're saying it's a perfect sphere now.
No, I'm not. For fuck's sake. Why do you have to do that, Beast? Really?
What is the globe?
We both know.
You know that's an orthographic projection, right? It's a 3D representation put onto a 2D map. That's it.
What? Say that again? The globe is a 2D representation of what?
No, the globe is a 3D representation of the orthographic view. The orthographic projection is basically a 2D representation. But if I showed you the orthographic projection, you would say, yeah, that's the globe. I bet you $1 million.
No, you showed me this the other day. And as soon as you said orthographic, right, it then flattens it out.
Hold on.
Yeah, we did this the other day.
How does
You're going to show me something that looks like a sphere, and I'm going to say, yeah, that's the globe.
What is that? What is that to you?
Yeah, is that a 3D image
what is that?
Flattened on a screen, or is it an orthographic projection?
It's an orthographic projection. Sir.
Okay. Right. So don't do that.
You think that's
do something in 3D.
You think that's the Earth, don't you?
If you said orthographic projection, no.
You see how
if you say that's a 3D figure, I'll say yes.
You see how retarded that argument is? Obviously, that's not Earth. It's just a representation of it. Obviously, the AE map is not Earth. It's just a representation. So by you saying, you guys think that's what Earth is, that's a retard argument. Thank you, Geo. That's
I think
the
I've made myself clear. Cool.
That's what every map is based off of that.
But you can't
the correct one is based off the graticule where lines of longitude converge at the poles.
Can't take a flat map and lay it on a globe without distorting it again, though. It would have to be distorted compared to the flat map.
Dude, take anything flat and try to put it on a sphere, it's going to be distorted.
Exactly.
Right. Yes.
What kind of fucking argument is that?
Right. Which one matches reality then? Either the flat one or the globe one.
Neither.
Yes, they do. Okay, show me one that doesn't match. Show me two places that doesn't match.
Reality, dude.
Right. Show me something in reality that doesn't match the prediction of a globe. 2 cities.
You guys are like fixing your ways, dude. I don't even care.
Dude, you said doesn't match.
Care if it's
show me something that doesn't match.
I don't even care. I just want to know the truth about the reality, about our reality. I wish you guys wouldn't gamify the discussion so much where you're just like, oh, I'll come here for the shit on flat earthers because they're dumb and it makes me feel special.
I'm offended. You think I'm British?
No, there's an Australian accent. It's perfect.
Yes. But you said it doesn't match. Show me something that doesn't match. Pick any two cities.
Yeah, but they're
Not
just
gonna
really
happen.
unsure about their model. That's the thing. What the truth of it is, they're just extremely unsure, and they feel like debating it. So it's kind of they think they're like punching down, but they're actually like grasping upwards.
Really
Trying
think
to
we're
figure it
unsure
out.
about our model?
Our model. Our model. One of us. One of us, Geo. One of us.
Yeah, the what's the word? Self-awareness is pretty low.
You're the most planar Earth curious people in the world.
No, I just
Yeah.
enjoy coming on here and talking to you guys.
I don't know. B said
That's the
something
only
doesn't
reason I
match.
do it.
Dude, I don't care about like winning. Like I just want to know the truth about this world. And I
Okay.
know I've been lied to since day one, because it's been the worldview that was drilled into my brain and into everybody's brain since like crib days, right? The little planets orbiting around while you're looking up from the crib and you're just staring at that. Like,
Does that mean it's wrong?
what do you mean? Does that, dude? It's not the point. The point is, it's a worldview that was forced into my head, and we were
Okay,
just
does
told
that
to
mean it's wrong?
accept it. We're just told to accept it. Same thing with, like the globe, right? The spinning ball, right? How come they introduced that into kindergarten, first grade, second grade, and then all of a
I'm
sudden
just
you don't
waiting for
use
the
it?
part where that means it's wrong. Just waiting to get to that part.
Yeah.
Why was
No,
you
that-
so fast to accept that it wasn't what you was told?
It wasn't so fast. Are you kidding me? I was the biggest astrophysics nerd you could possibly think of, bro.
How long did it take
Yeah,
you to
just like all
switch
these
to?
hardcore atheists found God.
Yeah, how long did it take you to switch then, to drop all that and think that it's not what they tell you?
When I started uncovering lie after lie after lie after lie.
About the shape of the Earth?
Like what?
A lot of things
Lie
that
about
include
what?
the shape of the Earth. I don't know. Do you think we come from the common ancestor Lucy or whatever the fuck? Do you think we come from monkeys?
How is that related to the shape of the Earth?
You just asked me.
Jesus.
You asked me a question.
So you start
the
with
shape of the Earth.
sort of not understanding or sort of not liking or denying evolution, and you tie that into the shape of the Earth.
No, he was being asked other things. You guys were asking him
Yeah,
questions.
yeah, yeah. That's
Okay,
fair.
sorry.
I just asked him.
You said
How
what
long
else?
it took
What was
him
the
and
other
what
lies?
what was the lies that, because he said a bunch of lies. He didn't
All right, it's your
specifically
fault,
say
Cole.
Earth lies. It's my fault.
Lie after lie after lie in terms of different subjects. That's what I meant by that. Lie to us about, what we're made of, essentially. That we're supposedly made of, these little, these cells that are basically made up of molecules, and like I have dopamine and serotonin and
But you're saying that's a lie.
carotene and all these things, that these chemicals essentially, and that we're just made of chemicals, and that we came from some type of,
Hold on,
hydrothermic vent
Beast.
that was
Where's
just
your
like some
proof?
lightning
Where's your
soup.
Where's your
And then
proof
all of a
that we're
sudden,
not made of little particles?
and
You're
then all
calling
of a
that a
sudden,
lie.
life just sprung up, and now we have, these amino acids that turn into like RNA, nucleotides, and then those strung together, and then that somehow just basically made, into another animal. It's like, dude, it's fucking crazy. It's so crazy that it has to go off of assumption, off of assumption, off of assumption. But when you actually look at like abiogenesis and evolution, and then the idea of what Earth is, and the stratification of like the different ground layers, and how far we've actually drilled, right? We've only been down 7.2 miles or something like that, and that's the Kola borehole or whatever in
Hey,
Russia.
is that a disproof
then-
of the shape of the Earth? Like, what are you getting
No,
at?
dude, it's the point of like what you actually know versus what you assume to know.
Okay, so hold on then. Let me go back just a little bit. You said that you think it's a lie that we're made of amino acids and all these things. These are things that we can physically test and prove. These are not things that we have to make assumptions on. These are things that chemistry
Prove it.
shows to be true.
Show
Now,
me,
if
show
you
me an amino acid.
now, if you want to
and tell me
say
that's what it
that,
looks like.
hold on. If you want to say that, did we start as some type of amino acid and evolve into this and evolve into that? I give you all of that. You can,
I don't.
you can say that that may be true, maybe not. But to say that the things that you can physically show in a lab right now that chemistry can show to be true, that's a big thing to just call a lie.
Show me a molecule that actually looks like the molecule.
Because we draw representations of what we think they look like. You think that
Yeah,
means
what
they're
do
not
they
real?
actually look like, Cole?
It don't matter exactly what they look like. What matters is their
Oh, okay.
behavior and the things that we can do with them and the things that we know that how we know that they're there. We may draw representations to make it easier to talk about them, but that's not that has nothing to do with showing that they're real or not.
So it has nothing to do with if they're actually in our body looking like that or not.
Is that what you're hung
No.
up on? That you don't think they look like that?
It's an
But we do have
assumption,
electron
dude.
microscopes, right?
We have electron microscopes, yeah.
Do they not give pictures of atoms or pictures of molecules?
No. What? No.
Really?
Yes, really, yeah.
Yeah,
Oh.
atoms, they just look like little itty bitty tiny circles laid out side by side. When you
Right, but the structure
I mean-
would match the diagrams, though, right?
No.
No?
What are you talking
So you do know how to do acetate tests or the Kaiser test in chemistry, and so on and so forth to detect the chemical wise amino acids.
Yeah, I mean, you would have to basically use other chemicals to dilute it to basically isolate it, which is another thing. It's like, how do you know you're not fucking it up by doing that?
Okay, have you ever done any chemistry?
No, but my sister has, and one of my
Yeah.
friends, Taylor.
Yeah,
You know her.
and when she looks for amino acids, is she looking for free aminos?
Taylor believes in amino acids.
Yeah, I know. Trust me, I know.
So no one in chemistry ever knows what amino acid is built of. Is that what you're saying?
Let's
We
see.
can't know. We can't know the chemical composition of an amino acid unless we can see each and every single molecule in the amino acid or
You
in
want to see what it
peptides
really
or
looks
whatever.
like? Hold on. We'll actually post this.
Hey, I want to ask Riff a question real quick. You were saying that we can calculate the speed in an airplane using the pressure gauge differential, but like in a car, you're trying to use a pressure gauge, the velocity calculation can be off as much as like 15 miles an hour. It's considered highly inaccurate. So like, isn't that a big issue? Because then we can't get an accurate measure of speed, right? Just from being in the air, we have to reference distance over time.
Wait, a car's
Hey,
not
see,
off up to
hang on.
15 miles per hour unless its wheels are the wrong size.
No,
Go ahead.
comparing it to the wheel. I'm using
Sorry,
a pressure
Ruhiff.
gauge
I'm sorry. Go ahead.
to calculate the velocity and comparing it to like the wheel rotation. In that
But you're
case, they're
saying
off by quite a bit. They're not considered accurate at all.
the airspeed indicator?
Yeah. Yes.
You think they're off by how much?
According to the AI, it's 10 to 15 miles an hour, which is very significant per car.
Airspeed indicator. No, for
Yeah. But if you have two cars going the opposite way at the same time, you average out.
Okay, I
If
get
you
what you're
knew
saying.
that the
All right.
wind was blowing one way.
Well, if a car, hold on, if a car's supposed to be off up to 15 miles per hour, every time I've ever in my life drove by one of them little signs that sits beside the road that reads your speed out, As long as I haven't got like big giant four-wheel drive
I'm only
tires on
talking
my
about
car, it
pressure
reads
gauges
the
here.
exact speed.
Cole, I'm only
Then-
talking about pressure measurements.
Well, then
Force speed.
well, I'm just saying I don't agree with your thing about the car. But
No,
go
I'm
ahead.
saying that the airspeed is
AI
off.
is 1 to 2%.
Yo, you guys see New Perspective's picture? It's actually hilarious.
Nice.
But yeah, I mean, you guys want to get into airspeed and stuff like that? That's fine. We don't have to get into the amino acids and stuff.
No, I just wanted to understand his debuncal of it. Like, I mean, yeah, go ahead.
They use a pitot tube to read airspeed on a plane, correct? Ain't that what they use, a pitot tube?
Yep.
I don't know how accurate those are.
It says 1 to 2% here, or 2 to 3%, sorry.
I'm not cool with pedos. I don't like pedos.
Not pedos,
Yeah,
pedos.
I kind of feel stupid for typing that in, actually.
Yeah, pitot tube is what we're talking about.
I definitely feel stupid for typing that in, and definitely didn't spell
The
it the right way.
worst form of YouTube.
It's PITOT, by the way, guys.
Yeah.
Yes.
Wait, how do you spell it now? Real question.
PITOT.
PITOT.
It's like a pivot.
Okay, I got you. Thank you.
Yeah, I've used handheld versions of them in the coal mine to read air through machinery.
It's actually pretty dope. That's so funny.
Wouldn't the gauge change based on your altitude because you're gonna have like different densities of air coming into it? I don't know. This is a new concept to me, so I'm fleshing it out. I don't see how these can be an accurate accelerate or velocity by themselves. And you would need them to be in order to not be deriving your distance traveled from the stars.
Wait, what kind of fluid do they use?
The air. I don't understand how the control one really works. But, I mean, I guess it's just like a neutral area. It doesn't really matter, I guess.
I don't know how they work depending on different altitudes. I don't know. I've never looked that up.
Did you just use water? Is it just like what? Just
air.
Yeah, water,
no,
air,
I'm
depending
saying-
on what you're using it in.
No, I'm saying, what do they use as the reference, like the liquid that's inside of it that's compressing and to what are they using?
Oh yeah, I get you.
I think it's air on both sides, isn't it?
I don't know. This is my
don't
first
know how
time
they
hearing
work.
about this thing. It's dope though.
The little handheld ones we just had in the mines was a little old box. It was maybe 6 inches by 6 inches. It wasn't very big. And it had a little flimsy rubber hose that came out of it, sort of like the little rubber hose on stethoscope that doctors have around their neck that they listen to your heart with, that type of little rubber hose. It had one of them on it. And then on the end it had an L-shaped 90-degree hollow tube that's made out of metal. And we measured the airflow inside of the miner, the machine that cut the coal. It has a thing called a scrubber on it, and it has air that flows down this tunnel on the side of it, and it has to flow at a certain rate. And you would thread a little thing off the top, a little bolt off the top, and it was a little hole that went down in that tube, and you stuck that metal 90-degree tube that was connected to your little machine down in there. It's a pitot tube, and then on the box it had a little readout in it, and when you ran the air through that tube on the miner, you had to make sure you oriented that little metal tube you stuck down in there to face the air, the way the air was moving. You had to face it, but then it would read how much air was moving through and how fast the air was flowing, and then you would multiply that by the size of the tube to get your amount of air flowing through that tunnel, that tube. That's how we had to do it.
But aren't the pilot
I don't know
tubes
how it
correct?
worked. Go ahead.
But I think there is like a correction factor as the air pressure drops. There's a calculation in the system that take care of that based on the Bernoulli's law, and they change the pressure.
Now I'm interested in how exactly they work.
Yeah, I'm on a deep dive right now. This is wild.
Yeah. And it's very core to like the argument you're having. The graticule point is very good, but like I mean, if they can measure airspeed accurately, not comparing it to distance, then yeah, that's an issue.
I don't know what you're saying, but yeah, this pedotube sounds so weird saying that. Compressibility, flow, and thermodynamics. Oh yeah, Bernoulli. Good old Bernoulli. By the way, Professor Phil, if you're still there listening, essentially that is what I vibe with in terms of like, I guess you would say, ontology, is that we're in an extremely tenuous ether, which basically, if we are an ether and it is dynamic, it also follows fluid dynamics, which makes a lot of sense, especially if you look at like magnetic lines of force, etc. And I just picture like a top-down energy that's basically pulling towards the earth or coming down from the top. It's actually what Isaac Newton was talking about in his second theory on gravity. It's like this toroidal motion. Like I really do think vortices and vortex, like I think all of that makes way more sense.
Yeah, here we go. I found one right here. Show it to you. This sort of looks like this. It's not the exact same thing, but it's close. I'll post it in the chat. Yeah, this is sort of like what we used in the coal mines to because it was by law your miner had to keep a certain amount of air flowing. This is what we used. I posted the picture in the chat there. Look like that, sort of.
Okay, I was watering the garden, so I didn't get a chance to talk to you, but I was interested to hear all this talk about the pitot tubes and to work out how airspeed was calculated. The less pressure there is, and it's consistent. It's very consistent. Right, so there's no question that we know that we know how high we are because we know what the pressure is. So now that's called the static pressure. Okay, right now. So once we know the static pressure, we know how high we are, and therefore we know the static pressure that we're at. Okay, so we now can say, well.
You should have been in here a while ago. It was last night. There was quite a bit of action going on in here last night.
Yeah, I could sense that the energy had peaked, and I just came in to mop up.
Yeah, I think it knocked it. Everybody fell asleep because it was like they just petered out. It was so energetic.
It's like a hot-blooded Australian guy for a long time. Talking science.
Yeah, and a professor. There was a professor came in here.
Yeah, that's who I meant, yeah.